So on in the background. Make sure you guys mute your watch pages as well. So
I don't have the watch. I don't have the watch page up. I don't put it up.
On my tablet, so.
Yeah, I'll shoot it too. Just stand by. Stand by, stand by, stand by. So
I don't have the watch. I don't have.
Yeah. What's up, people? This is Robert Bassano. I got John. I got Luke. Welcome to Planete Veritas. We are going to be talking about some interesting things today. You guys see the title of today's show. It's called What is Really Happening When We Can't Observe? And I say nothing at all. John may say something different. And Luke's got some information to give to people. I've got some things to share. Guys, everything that we talk about, I'm learning. We're all learning. There's stuff that we may think we know a fair amount about that we're sharing with you. I'm not saying that we're trying to teach anyone anything. We're just trying to get some sort of understanding of what's really going on. That's what it comes down to. So the information we share with you guys, you gotta come to your own conclusions on what you want to believe, what you can't believe, what you will consider, and what you won't consider as viable, plausible, possible. Okay? Remember, it's not what you know, it's what you can prove. But just because my proof is what I'm putting out doesn't mean that it's true. Just because what John says and the proof he provides doesn't mean you have to accept it, and so on and vice versa. What we do need on a continual basis is constant feedback. I'm getting a lot of emails from people wanting to have things explained and trying to look at as much information as I possibly can, you know, while I'm going through school and learning this on the fly. I'm learning it on the fly. So what I'm sharing with you guys and what we're all sharing with you guys is stuff that you might already know, stuff you've already been exposed to, stuff you might not know. But what we're trying to do is just put this like a research paper. You need to have a research puzzle. And you got to get all these pieces together to come up with some sort of conclusive statement or claim that this has to be it. And then leave it to someone else to say, no, that's not it. I've tested that, and here goes what it should be. Not what it is, but what it should be. Okay? And then you just keep going. It just keeps going and keeps going and keeps going. The reason why we focus a lot on the quantum level these past couple of weeks, why we've been talking about this, is because we can't start from where we're at right now, looking at the Earth, looking at our environment, trying to decide, okay, we got to go backwards now. So we're taking everyone backwards on the quantum level, the smallest possible level, and then we're going to try to grow everything outward to come up with the construct that we all see every day and everything that we experience. Okay? And I promised John and a few guys that I would always start the show with playing this one video that I have on my channel, which I'm not going to say basically, but factually shows that the Hubble is nothing but a 43.5-foot tall piece of junk, and it's not where they say it is. And everything NASA do, like we always know, especially with the mass media, is fabricated. So I'm going to just show this quick snippet of this video that's on my channel. Okay, it's called Flat Earth. I think it was called Flat Earth Bullshit. I think that's what I named it. But I'm going to pull it up and show it to all of you guys one more time. As long as we do these shows, I'm going to just keep rerunning this. NASA likes rerunning shit to us all the time, so I'm going to rerun it as well. It's their information, right? It's their information. Let me, so here we go. Play this for all you guys. And again, I want you guys to pay close attention to what this astronaut's movements and You know, in the same frame, pay attention to what the Earth is doing below. Of course, we know that's not the Earth. And pay attention to what this Hubble is supposed to be doing, okay? Just focus on this area right here. Just focus on this. Watch the astronauts' movements. Watch what everything else does. And just have a good laugh, okay? There we go.
Fucking incredible. Absolutely. Wait a minute. We need to go back. Did I just see what I thought I saw?
Sorry.
Did the fucking Earth stop moving? Did I see what I saw? Wait. Hold on a second. This is what I want you people to pay attention to. I'm going to play this again. And I want you to take quick notes. Let's try this shit one more time. I want you to look at this video. And I want you to tell me what you see. The Earth's supposed to be moving. Oh, did you fucking see that? Let's do that again. Let's go back again. Here we go. The Earth's not moving. Ooh, you're free. Fly and be free. Holy shit. Let's do that again. So you saw it. The Earth's not moving. Boom. Start it back up again. Did you see that shit? Holy fucking shit. Look. The Earth's not moving. Boom. Anybody want to fucking tell me that's some fucking video glitch? You want to tell me that's a video glitch? You see the astronaut moving, right? The astronaut's movement is seamless, right? So let's see this again. Astronaut's hand moving, the Earth is moving now. Are you fucking kidding me? I dare anybody try to fucking debunk this. I dare anyone try to debunk that shit. Two things. They said this mission was canceled. The spacewalk. These two yahoos are outside of the fucking space shuttle. And then we are forced to believe that this shit they're doing is real. Look at the Earth. The Earth fucking stopped. I need to do that fucking in slow motion, man. Hold on. I need to do that in slow motion, man. Let me do that again. Let me do that again. Let's change the speed of this bad boy. Let's change the speed. I'm gonna do it to a quarter speed. I'm gonna do it at a quarter speed. And here we go. Quarter speed. There goes the astronaut. The Earth's not moving. They release their hands. Now watch. The Earth's not moving. Is the Hubble attached to the Earth by some fucking tether? You gotta be fucking kidding me, man. You have got to be kidding me. I mean, I'd be stupid to say it. I don't know what to say. I'd be stupid to say it. I don't know what to say.
Okay, there you go, people. I'll put it in chat for everybody. And I'm going to give the show away to John. John wants to touch base on a few things that he said for the last show. And Johnny, take it away. You're going to be presenting to everyone. And go for it.
Hey, thanks, Robert. Are you guys seeing my screen?
I think I did. I presented you to everyone. Hang on.
Okay.
Okay, hang on. Do the present, John.
1 second. So screen share.
Yeah, screen share. We don't. Okay, there you go. Present you to everyone, and there you go. It's all yours.
Hey, thank you, sir. So listen, I wanted to make sure that we didn't lose the punchline of the presentation that we did the last time. Make sure that we didn't lose it in translation. So the punchline here is there's nothing wrong with actual real science. Scientific method, it's empirical and it's logically sound. Here's what's wrong. It's the pretenders, the blue and the red guys. See, when you walk in any educational establishment from grade school through university, science is engraved in gold on the arched ivory entrance where you genuflect before entering, right? But these so-called disciplines aren't science. We just showed why. They don't and inherently can't follow the scientific method. How on earth can you be science when to be science you must follow the scientific method? How can something be a something without having any attributes or characteristics of that something? I mean, is this a eucalyptus tree? Then why are these guys called science, for crying out loud? Crocheting is more scientific than these clowns. They're merely masquerading under the term science and have legions of incoherent fans that merely parrot and propagate that it is science. You know, you always hear it, well, science says blah, 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 right? No, it doesn't. Science doesn't have any vocal cords, penmanship, or typing skills. It's not alive. And they're not scientific. So science and the scientific method isn't the problem. It's the fraudulent fairy tale masquerading philosophers flying their incoherent flag under something they're not. So these astrophysics, astronomy, and cosmology, these are the very disciplines telling you that the Earth is a spinning ball, among other numerous logical and scientific atrocities. They're only philosophers with fallacious scientific initials behind their names. There's a big difference between scientific claims and claims that alleged scientists make. And check this out. This is Andreas Osiander. This is the foreword to On the Revolution of Heavenly Spheres, which started it all, or codified it. Anyway, in 1543 by Nicholas Copernicus, right? So listen to this. So far as hypotheses are concerned, let no one expect anything certain from astronomy, which cannot furnish it, like we've been talking about. Lest he accept as the truth ideas conceived for another purpose, and depart from his study, or from this study, a greater fool than when he entered it. So, and this is confirmed in a big way here. Renowned cosmologist George Francis Rayner Ellis, and I quote, "People need to be aware that there's a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds." Check that. So, welcome to philosophy or religion. Only these orders have calculators. And this one speaks volumes. Cosmology may look like a science, but it isn't a science, like we were talking about. A basic tenet of science is that you can do repeatable experiments, but you can't do that in cosmology. So when blind parroters or so-called scientists inevitably wheel out their disheveled train wreck mantra, well, science says, well, this is the ammunition you need, and the ammunition is ICBMs. Go ahead and launch them. So you can destroy them even before they start out. They're philosophers. So there you go.
You know, there's a guy in chat, Scientism. He spells his username PSY, and he actually used the word science, spelling it the same way, saying that it's not science. It's basically a psychological mantra they're pushing.
Exactly.
They're trying to convince you You know, this is what we say it is, and you can't challenge this. We need you to believe this.
That's correct.
Don't ask us how we came up with it. Just understand we put our minds together to agree
That's
that,
correct.
you know, this is the shape of the earth. This is how it works. But can we observe it? No. You can't. They won't allow you to go 90 degrees vertical high enough to actually see the shape, construct, and function of the earth. Period. I mean, when you look at the earth, what they claim to be, you know, from hundreds of thousands of miles away, you don't see the way the atmospheres actually rotate and function and move. You can't even judge the distance, because when they're claiming that they're showing the ISS, right? People say, yeah, can't you see the Earth is rotating? The Earth is rotating. No, the Earth is not rotating. What's moving is supposedly the ISS is 17,000 miles an hour, giving you the appearance and perception that the Earth is moving. And when I said that to someone, they were like, well, you know, we just have to assume that this is the speed it's probably moving at. But you can't get anything up there to stay stationary long enough to make a determination that the Earth is actually moving. And when I say Earth, people, I'm talking about the fixed plane surface. I'm not talking about the other layers in the atmospheres. There's obviously movement up at those levels. But it was interesting to read this comment from this guy in the chat that science should be spelled P-S-Y-E-N-T-I-S, T-I-C-E, science, because it's really it's all psychological.
Well,
it's all psychological.
Well, the masqueraders are using science. You know, science isn't the problem. If they would follow science, you'd never hear from them. So they're masquerading under the name of science, but they're not science. See what I'm saying?
No, it's if we can agree that there's no such thing. What we said the last show, that there is no such thing as science. It's a collective agreement. It's a method.
Science. I mean, it's the scientific method, but they can't use it.
Is there really science?
Yeah.
Is there really science?
Yeah, it's the scientific method, but these guys can't use it. So what they're telling you is science isn't science. They can't follow the method. Yeah. So that's what the deal is.
Okay. I want to go. You want to go to the delayed choice quantum eraser?
Yeah, the granddaddy of them all.
Now, do you want to go to the video first and then go to that? The double slit experiment video, because I put it right on 3 minutes and 33 seconds.
Yeah, I got it right here too.
All right, pull up the go to 3 minutes and 33 seconds.
Yeah, I got it right here.
Yeah, it starts there.
Yeah.
And then what we'll do, we'll show everyone that, and then go to the quantum eraser document, break that down, and then I'm going to do my whole critique thing. So
yeah, that's fine.
Because I'm going to be honest with you. You asked me to look at this several times. I did, and I'm looking at it and I'm thinking to myself, I'll just let you go with it and I'll tell you. I'll share it with everybody.
Okay. Is it
go ahead.
sharing?
Yeah, it's sharing. You're still sharing.
Okay, this is the granddaddy of them all. This is the
blow up the screen. Blow up the screen so everyone can see it.
So. Oh, I see what you're saying. Okay.
Yeah.
Better?
Yep.
All right. This is the granddaddy of them all, a delayed choice quantum eraser. This is a double slit experiment on nuclear steroids. In all my travels, I have yet to come across any experiment that comes close to the simple and elegant brilliance of this bad boy. And the results are even more breathtaking than the actual experimental design. And once they're understood and reckoned with, it'll become clear. So here we go. This is a good explanation of it.
Quantum eraser experiment.
Is it playing? Is the audio playing?
Yes. Can you hear it?
Can't hear anything.
Can't hear nothing.
You can't hear anything? Maybe, hey,
Nope.
Robert,
Nope.
can you play it?
Yeah, let me play it from my side.
Okay.
Let me play it from my side.
All right.
Okay, let's see here. Play it from my side. There we go.
Measurement equipment was not available, thus the experiment was first performed in 1999. Even though the setup looks a little complicated, you will have understood it in a few minutes. Behind the double slit, a beta variable rate crystal is used, which causes the photons from either slit to split into two identical entangled photons with half the frequency of the original photon. Why the splitting is required will become clear in a minute. This yellow lens has the task to redirect photons which have traveled through the first slit and thus on the red path, and photons which traveled through the second slit and thus on the bluish path, so that either one hits the sensor D0 at exactly the same location. The intention behind this is being able to measure at sensor D0 whether a bar or a diffraction pattern is being created by the photon, without being able to determine through which slit the photon originally traveled. The information about which slit it came from is deliberately erased by only using one sensor, which cannot distinguish which slit the photon came from. Now let's first take a look at the red path. A photon flies through the first slit and is split into two identical photons at the beta barium borate crystal. The first of the two identical photons flies towards the yellow lens. The second flies downwards and is redirected by two prisms until it finally hits this green semi-permeable mirror. These three green mirrors have all the same attributes. The green mirror allows light to simply pass through 50% of the time. In the other 50%, the light is completely reflected and thus redirected. The decision of which path the photon travels at these green mirrors is a random process with a 50-50 chance. On average, every second photon is redirected upwards and hits sensor D4. In the other case, the photon is not affected at all and simply travels through the mirror. It then strikes this gray mirror, which simply reflects it, and it reaches this second green mirror. Unfortunately, the depiction of this second green mirror is slightly incorrect, and it should rather be oriented as indicated here, so that the reflection angle matches the setup. From now on, simply...
Now hang on for a second, Jay. I want to stop this to go back to when we first did this. That one video we did with the cartoon animation where when we first talked about the double slit experiment, the problem I had with I looked at this 3 times before we did this show, okay? And it dawned on me. Remember the first video we showed with the cartoon? The guy says that the actual placement of the detector right at the entrance of where the photons would be going through the double slits, that when you actually put the detector there, somehow the photons are aware they're being observed, and they perform completely differently just based on the act of observation. Meaning that some mysterious phenomena, the photon realized it was being watched and didn't behave the same way when there wasn't a detector there. So when we look at this experiment, where we're looking at what? We're looking at 1, 2, 3, 4, 5 detectors that are set up in particular locations, reflecting and refracting light. And then you have the coincidence counter at the end, which is wired up with the detectors, and this guy's giving statistics of, 50% of the time the photon of light doesn't even go through. It actually gets reflected back off and goes in another direction to another detector. See, if you take out the detectors, what happens? What happens if you take out these 5 detectors and you just observe with your own eye to see what, and you still have, I mean, that would mean you don't have the coincidence counter. And that's why I titled this show, What's Really Happening, when we can't observe. Is this double slit experiment actually occurring the way this guy is actually describing it in this video? Because you have 5 detectors, which means that the photons are actually behaving the way we would collectively expect them to behave based on the angles and positions of the detectors, the prism, the other mirrors, their angles, their compositions. You understand where I'm coming from with this? Is that first video we did, where the scientist actually said that the photon behaves completely different when it's being observed versus not being observed. This experiment, based on that first video, is completely invalidated for me.
No, it's not. Let me explain something to you. In that first video, the photon detectors were placed. You see where the blue laser right over by the BBO crystal?
They were placed on that side of the blue of the double slit.
Yeah, right at the double slits. In this case, they've taken that out of the equation and they moved the detectors downstream.
Okay, and I factor that in. But who's to say that the same thing, just because you change the position of the detectors, you put them on the other side to observe what the photons are doing once they go through the double slit, who's to say the same thing isn't happening on the other side? Where the photons are actually know that once they go through the double slit, there's not a detector on the left-hand side when the photons are fired through the double slit. But as soon as the photons go through the double slit, it says, oh shit, we're being watched, put your clothes back on. We need to perform the way we would if we were being watched on the other side. Everyone get back in line. That's the simplest way I can explain it. There's no way of, see, this experiment, for me, doesn't prove that the same thing is happening on the other side, even though the detectors have been placed on the actual observatory side when the photons have gone through the double slit.
Okay, well, let's see. Go ahead and run the rest of it.
Okay.
Let's see what they say.
Turned by a few degrees. In the first case, the photon is not affected by the mirror, simply travels through it and hits sensor D1. In the second case, it is reflected and hits sensor D2. Now let's take a look at the bluish part of the photons which travel through the second slit. They are also split up into 2 identical photons, and the one traveling downwards is also redirected by prisms. At the first green mirror, every second photon is reflected and hits sensor D3. In the second case, the photon simply travels through the mirror, hits this gray mirror, and subsequently this second green mirror, which you should again imagine to be turned by a few degrees. 50% of all photons travel straight through this mirror and hit sensor D2. The other 50% are reflected and hit sensor D1. First of all, you should understand that photons which traveled through the first slit and thus on the red path can only reach sensors D1, D2, and D4. They can never reach sensor D3. Which of these 3 sensors they actually hit is a random process that depends on the green mirrors, but they will inevitably reach one of these 3 sensors. The same logic applies to the bluish paths. Photons which travel through the second slit can only reach sensors D1, D2, or D3, but never sensor D4. Thus, it should be clear that a photon that hits sensor D4 inevitably traveled through the first slit, because photons who travel through the second slit have no way to reach sensor D4. The same logic applies for sensor D3. Any photons reaching it must have traveled through the second slit.
Quick second. Now, he used the word logic a few times. Now, correct me if I'm wrong here, he's saying that the photons going through the blue slit can never reach D4 unless, then the only way to reach the fourth detector is to go through the first slit. And this is why I say, what's really happening when we can't observe? Now, let's just say for argument's sake that the photons going through the second slit, the blue slit, if they can reach detector 0, right? And again, these photons are being fired at the same time. So the photons going through the first slit can travel to detector 0, and the ones going through the second slit can go through detector 0. But what's to say that the photons going through the second slit, the blue slit, somehow don't interact with the photons from the first slit, join up and fuse together to get to the fourth detector? Because but he's saying that it doesn't make, if you use logic. But let's throw logic out the window on this whole thing.
Robert, look at this experiment. On path A, the red path, the only way a photon can hit detector D4 is to come out of A. You can't, if a photon would come out of the blue path, it can't reach D4.
Yeah, but what rule, what law says that that's not possible?
It's right there in front of you. There's no path to it.
I'm looking at it, but what law or rule dictates that that can't happen?
Because the photon is traveling directly to that beam splitter. It can't get to D4.
When you look at this chart, it shows photons going to the 0 detector.
Yeah, because it's designed to. You've got 2 photons, entangled photons, that are generated right after it goes through the double slit. One goes to detector D0, and the other one goes on the path on the path in the experiment. The D0.
So this prism, this Gland-Thompson prism,
right,
which is allowing for these photons to be reflected and refracted to go into these directions. What you're trying to say is that there's no possible way, based on the shape and design of this prism, that photons coming through the second slit don't somehow bounce off the photons from the first slit and then take a linear straight line straight for detector 4. You're saying that is not possible.
That's not possible because there's only a single photon being generated by the laser, and that single photon is split into 2 entangled photons. They're sister photons. One goes to D0.
Sorry about that, guys. Damn it.
Yeah, every time a photon is sent into this experiment, it's split into 2. One of those gets sent to D0, and the other one goes on either of these paths in the rest of the experiment.
Now here's a weird question, which when I looked at this, I started looking to see if someone did this experiment where they actually changed the temperatures of the prisms. Because here's a testable hypothesis. What if you change the temperature of the Gland-Thompson prism in the beginning?
I don't know. Can we?
And that's my point. That's what's really happening when we're not observing. We don't know.
That's not a point. Well, we could put jelly on them too.
Yeah. Well. Yeah. Okay. I'll go about that one. But I'm telling you here right now, for me personally, I don't believe this.
Okay. Well, let the experiment go.
When I look at this, when I look at what's here, there's a possibility. He's saying 50% of the time, the photon actually gets reflected off to hit this mirror.
Yeah, that's a beam splitter.
But why wouldn't it be possible for this to get reflected off and go immediately to D4 without hitting the mirror?
Well, it either transmits through the beam splitters or gets reflected off. It's due to the angle of the beam splitter.
So they're basing everything on the angles of these prisms and the way they're actually maneuvered to get the light to reflect. But if you change the angle and the position of this prism and this prism, you could literally there's a potential possibility you could get the particles from the second slit to go straight to D4.
Yeah, but that's not set up that way.
Yeah, but why is it set up this way?
Because
And they don't show multiple experiments of changing the angles of these two prisms to see if they can actually get both particles to go straight to D4.
Robert, because that's not the experimental setup.
Yeah, you see, it's another.
Just go ahead, let it run.
Another psychological.
Let it run and let's see the...
Say, you know, something else can't happen simultaneously at the same time.
Yeah. Let's run the experiment and see the results, and then you explain the results when it's done.
Yeah, let me finish playing this.
Go ahead.
For photons which ended up in sensor D1 or D2, it is impossible to determine through which slit they actually traveled, because those two sensors can be reached on the red path from the first slit, as well as on the bluish path from the second slit. Now you have almost understood the setup of the experiment. One element is missing, and that is the function of sensor D0 at the top, and the reason why the photons traveling through either slit had to be split into two entangled photons by the beta variable rate crystal. Sensors D1 to D4 are identical sensors. They can only detect that a photon has hit the sensor, but are not recording any image, whereas sensor D0 is similar to a camera and is able to record the exact location where the photon ended up on the screen. The last aspect that needs to be understood before looking at the results of the experiment is related to the time it takes the photon to travel through the experimental setup. Light travels at the speed of light. Thus, the shorter the path, the earlier the photon reaches the sensor. The experiment is designed in a way so that the path of the photon traveling towards the yellow lens always reaches sensor D0 first, before its entangled partner reaches the first green mirror. Thus, the result of the measurement of sensor D0 is always recorded first, and then, with a short delay, the partner photon hits one of the sensors D1 to D4. The coincidence counter on the right has the task to process the results of the measurements of all 5 sensors. It establishes a connection between the measurement results of sensor D0 with the entangled photon detected by sensor D1 to D4. This way, each single photon measured by sensor D0 can be precisely assigned to one of the sensors D1 to D4, where its entangled partner was measured. The measurement data of sensor D0 can thus be split up into 4 individual images, each assigned precisely to one of the sensors D1 to D4. This picture depicts the raw measurement data of sensor D0 on the upper left. This raw data only shows a white bar of light in the center of the screen. So, in this raw state, this data is pretty much useless. It is only when each individual spot of light of the raw data is assigned to the sensors D1 to D4, where the entangled partner photon was measured, that a pattern becomes visible. 2 aspects stand out immediately. The data assigned to sensor D1 and D2 shows an interference pattern, while the data assigned to sensor D3 and D4 shows no interference pattern. For photons which reach sensor D1 or D2, it is impossible to determine through which of the 2 slits they traveled, since the path information has been erased by the 50-50 chance events at the green mirrors. The entangled partner always creates an interference pattern, similar to the double slit experiment without photodetectors at the slits.
Wait. I remember seeing this and listening to it. Why the hell would the information be erased?
Because if you look at the experimental setup, any photons that hit D1 or D2 is obfuscated here in the experimental setup, because it can come out of path A or path B. You see the blue and red lines?
Yeah.
There's no which path information you have. It could be A or B. But
so the fact that the coincidence counter can't determine which slit the photons came out of once they hit D1 or D2, because it can't detect where the photons came from, it immediately just erases the data?
No, it's comparing. You're getting data. See, when these photons are hitting these detectors, D1, D2, D3, and D4, they're not taking any measurement, like position measurement. The only measurement is being taken at D0 from its entangled photon that was fired 8 nanoseconds before it. So these are just sending electrical pulses to the coincident counter.
But it's detecting something that hit. It's detecting photons that hit D1 and D2.
Yeah. Yeah. And the interference pattern or the no interference pattern is showing up on D0.
Okay, but how do they determine there's no interference?
They're showing you right here. These are the patterns that are coming out.
When he talks about the data being erased, I'm taking that is that the data is not being erased.
No,
the data is still there. No. It's just not on a detectable level.
No, the data is not being erased. The path information is being erased.
Okay, well, okay, let me correct myself. Path information. The path information is being erased not because it shouldn't be accounted for. It's there. It's not detectable.
It's just obfuscated. Correct, Robert. It's a better word would be to say that it's not erased. It's just obfuscated. You don't.
But why would they say that it's being erased and just saying what you just said, obfuscated, and that it's still there, but it's just not at a detectable level for the experiment?
Yeah, they just call them eraser experiments. It's the same thing, obfuscated or erased.
Yeah, that just kind of explains why we keep fucking making mistakes in a lot of shit.
Yeah, it is a language.
If it can't be detected, they're just saying, okay, it just doesn't exist. Which means that when we're not looking, there's a whole bunch of shit happening we just can't observe. And we come up with all of this science and this mathematics to try to explain, well, you know, you can't account for this data because this data is not consistent with the majority of the data that's being put out. So the fact that we can't explain it, why don't we just discard it?
Now, look at what you have here in your results. Detector D1, D2, D3, and D4. Why are you getting an interference pattern at detectors D1 and D2, and you're not getting them at D3 and D4? So you need, and the only explanation is because of the experimental setup. D3 and D4. Whenever a photon hits one of those detectors, you know exactly which path it took because it can only take one path due to the experimental setup. Right? So it's only one path.
The way to make this experiment better is to conduct simultaneous variants of this experiment, changing the mirrors so that you could actually get the same pattern that you have on D1 and D2 with D3 and D4.
You can't. The only way you can do that.
Yeah, but John, come on, bro. Listen, you know,
the results
you keep saying we can't. That word just don't jive with me. You saying we can't, but no one's done it.
Well, Robert, look at these results.
I know, I'm looking at these results. But when you say it can't, there's no way an experiment can be conducted so that you get the same pattern on D3 and D4. The fixed positions of these detectors.
Yeah, there is. Yeah, there is. All you have to do is know the path information, and you can duplicate these patterns.
Okay, so how would you go about nulling the path information?
You know, set up the experiment where there's only one path to that detector, like in this experiment. It's already doing it for you.
Yeah, and the way the experiment will be set up is changing the angle of those prisms.
It's got to do, yeah. I don't understand where you're trying to go with it.
No, I mean you do, Jay. Come on, the prisms is what's directing the photons.
Don't worry about the prism. Don't worry about the.
Don't worry about the prisms. That's
they're not. They're.
The prisms are affecting the path.
Yes, because they're set up that way.
Okay, so you're saying don't worry. If I take the prisms out of it, what happens?
If you then you don't have any experiment. You're not doing the experiment.
Okay, so the double slit experiment has been debunked.
It's not debunked. Let it go. Let it go. Let's go ahead and finish it.
Let me see.
For photons which reach intensity 3 or D4, the path of the photon through the first or the second slit can be identified. The entangled partner does not create an interference pattern, similar to the double slit experiment with photon detectors at each slit. Why should this result really make us think about the nature of reality? Well, The problem with this result is that the photon that travels on the upper path reaches sensor D0 at a time when its entangled partner photon is not even in the first green mirror. At this moment, the photon cannot really know whether it should create an interference pattern or not, because due to the longer path, the result, which sensor its entangled partner has traveled to, is still undetermined. How can the upper photon know in advance for each individual measurement on which path its entangled partner will be traveling through the green mirrors? It cannot know, because this decision in the green mirrors is a random event with a 50-50 chance. Nevertheless, the results show that obviously the upper photon knew exactly what to do in each case. Otherwise, the data assigned to sensors D1 or D2 would not form an interference pattern, while the data assigned to sensors D3 or D4 shows no interference pattern. Did you grasp the paradoxical nature of the results of this experiment? In case you didn't, maybe jump back and rewatch the last few minutes. What do scientists have to say about the results of this experiment? When approaching the results of the delayed choice quantum arrays experiment with Newtonian physics and a purely materialistic worldview, there is no way of explaining its results. Thus, many scientists simply avoid the entire topic because it seems as if causality and time are being violated here. While the formulas of quantum physics can describe the effect mathematically, it is difficult for any layman to grasp these rather abstract derivations and conclusions. As an alternative to these sophisticated formulas, I would like to present you now in the third chapter of this video with a model of reality physicist Thomas Campbell has come up with, because his model can explain these strange results in easy language.
You want to go down here, Robert, or you want to stop it?
Reality is a workshop in about 16 hours. Since only
well, that's up to you. Do you want to go into his discussion?
No, I don't want to go too far into it. It was interesting that he says that because this defies what they it defies what causality in time.
That's right. Exactly.
They want to stick to the Newtonian and Einstein. They want to stick to the Einsteinian idea of causality in time. And because they can't explain this, they're just like, okay, whatever,
Yeah,
they'll use this.
Yeah. I've had many people. I've brought this up to university professors. They just start calling me names. Listen, this experiment, in summary, it shows that knowledge existing or knowing the which path information alone causes wave function collapse.
Yeah.
Number two, decoherence, that is the physical interaction of quanta with a measuring device, does not cause wave function collapse. And number three, QM phenomena transcend space and time. That means they are utterly meaningless and causality is violated. So you can't get around it. You can't get around it.
You want to pull up the document on delayed choice quantum eraser?
The actual study?
Yeah.
Go ahead.
Let me pull it up. Hang on a second.
And
yeah, I'm not saying that I completely. Well, I'm not going to make any claims that I understand that fucking thing because.
Well, it takes about 50 times.
The fact that it's a static experiment is what it is.
What do you mean static?
Well, static meaning that they decided, okay, probably through their own experimentation, let's stick with this variable we put together because they've probably tried a multiple of variables to determine which position the prisms had to be placed in, the angles of the mirrors.
Robert, all the prisms and all that stuff is a basic interferometer.
Well, I would have loved to see the actual physical experiment in a video.
Yeah, I would love to see it too. But go ahead and pull up the actual study.
I'm pulling it up right now. I'm pulling it up right now. Pulling it up right now.
All right, go ahead and scroll down to the left-hand side.
Yeah, hang on. I just pulled it up. So this is the delayed choice quantum eraser study. It's based on that video we just saw, people. Where do you want me to go to?
Yeah, go down the left-hand side. Go down one more. Okay, hold up. Go ahead, scroll up a little bit. Okay. Start reading. Just start reading from "We Wish." It's a new paragraph that's down in the middle.
Right here.
Yeah, go ahead.
Okay. Let me pull that so everybody can see that.
Okay.
Okay. We wish to report a realization of the above quantum eraser experiment. The schematic diagram of the experimental setup is shown in Figure 2. Instead of atomic cascade decay, I don't even understand where that even played a role in this.
Well, that's because they did that. Just keep explaining.
Yeah. Spontaneous parametric down conversion is used to prepare the entangled two-photon state. Jesus. The spontaneous parametric down conversion is a spontaneous nonlinear optical process from which a pair of signal Euler photons is generated when a pump laser beam is incident onto a nonlinear optical crystal. In this experiment, the 351.1 nanometer argon ion pump laser beam is divided by a double slit and incident onto a type 2 phase matching nonlinear optical crystal BBO at two regions, A and B. A pair of 702.2 nanometer orthogonally polarized signal Euler photon is generated either from A or B. The width of the SPDC region is about 0.3 millimeters, and the distance between the center A and B is about 0.7 millimeters. A Glenn-Thompson prism is used to split the orthogonally polarized signal and Euler. The signal photon 1, either A or B, passes a lens LS to meet detector DO, which is placed on the Fourier transform plane, focal point plane from a collimated light beam of the lens. The use of lens LS is to achieve the Fairfield condition, but still keep a short distance between the slit and the detector, DO. Detector DO can be scanned along its x-axis by a step motor. You know what? Let me tell you what. This is...
Keep going. It's going to tell you here in 1 second.
Dude. This is highly fucking complex for everybody that's probably listening in chat, dude, because it's fucking scrambling my brain right now.
Okay, it says the
process that took place.
The interferometer.
The interferometer includes a prism PS2 50-50 beam splitters, BSA, BSB, 2 reflecting mirrors, MA, MB, and a 50-50 beam splitter BS. Bullshit.
There you go.
Bullshit.
Yeah, BS.
That's what I have to say. Bullshit. Yeah, they got that right. They got that right in this document, because let me tell you something. I'm reading through this and I got it now. I got this. I got this now.
You do?
Yes.
Okay, then go ahead and explain the results.
No. Hold on. Let me read down to this part right here.
Good.
Detectors during a detour are placed at the two output ports of the BS, respectively, for erasing the witch path information. They set this fucking experiment up to literally create the invalidation of the undetectable path.
What?
No, because remember when the guy says that the paths of those two photons are erased?
Yeah, they're obfuscated.
You want me to go back? They are obfuscated. They didn't use that in this paper.
It's the same thing.
Oh no, it's not the same thing, John, to me. What they're saying is that, well, we couldn't set up the experiment to detect everything. We could only set up the experiment to literally recreate the possibility that the photon path, we know it was going to be undetectable because there's a 50-50 chance it will or will not show up. So we're going to set the experiment up to prove what we believe may be happening. All
right. Go ahead and explain the results.
The triggers of detectors D3 and D4 provide which path information of the idler, photon 2, and in turn provide which path information of the signal, photon 1. The electronic output pulses of detectors D1 and D2, with this paper go all the way back up, D3 and D4 are sent to coincidence circuits with the output pulse of detector D0, respectively, for the counting of joint detection rates R01, O2, O3, and O4. In this experiment, the optical delay is chosen to be equal to 2.5 meters, where L0 is the optical distance between the output surface of BBO and detector DO, and Li is the optical distance between the output surface of the BBO and detectors D1, D2, D3, and D4, respectively. This means that any information one can learn from the photon 2 must be at least 8 nanoseconds later than what has learned from the registration of photon 1, compared to the 1 nanosecond response of the detectors. So wait a minute, wait. So the detectors have a 1 nanosecond response time, but they're saying the actual detection is not taking place till 8 nanoseconds later.
Yeah, the difference between D0 is hit by a photon 8 nanoseconds before any of the other detectors are hit.
Yeah, this whole experiment just looks completely bullshit contrived. Yeah, I agree with him. It totally goes against what the rest of science wants us to believe.
Every experiment is contrived. That's the whole point.
Well,
you have to contrive it. You have to have controls.
Well, I don't agree with the obfuscation that they're just totally disregarding the fact that there's something happening. They just can't detect it. So
they're not disregarding anything. They're sending photons on one of two paths. One path is a known path. The other path is an unknown path. If you send these two photons on a known path and an unknown path, what happens? What is the result? So on a known path, there's no interference, clearly from this experiment. On an unknown path, there's interference. That's what it's telling you.
You remember the first show we did and what you said, right?
What?
With regard to information.
Right. Which path information? Correct.
Which means that something is sending that information to that photon to tell it what to do.
No. Well, the experimental setup hides the independent variable in this experiment. The independent variable is known path versus unknown path. And you have two unknown paths. Detectors 1 and 2. Detectors D3 and D4 are known. So look at the detectors and tell me why D1 and D2 show interference and D3 and D4 don't. Okay,
forgive me for this. I want to use a little bit of logic, like this guy said in the video. Logic. Let's go with what you said. Known path and unknown path.
That's correct.
Okay. How could there be an unknown path when they actually describe how they set up the whole experiment?
Pull up the experiment.
Get the experiment up. They describe how they set this experiment up, which means that they already know what's going to happen.
No, they don't. They put this is an experiment. It's judging two outcomes. A known path, you set up a known path, and then you set up an unknown path, and then you look at the results and say, is there any difference here?
But I'm going back to logic. How can you set up an unknown path? Listen to the words. Unknown. How can you set an unknown path? That's like saying, hey, you know what? Let's go inside this cave. Luke, you go down there. I know where that goes to. Robert, you go down there. I'm going to go down here because I've never been there before.
Robert, it's the experimental setup. Look, pull the experiment up again.
That's what I'm saying. We're both going into the same cave. We're just going down different rabbit holes. You know.
I'm going to show you. Pull up the experiment. Pull up the design of the experiment. Go back to the video. I'm going to show you how you do it.
Okay, hang on a second.
Yeah, go out of this. Pull up or give it to me.
Well, go in the watch page and click the link.
Okay. Screen share.
Are you sharing your screen?
1 second.
I'm just.
1 second.
I'm not sure. Am I not getting it?
Yeah. Well, it's, you know what? This is a pretty complicated.
That's how I look at it. I look at it as though me, you, and Luke are going into the same cave. We're just taking two different directions, and you're saying that there's a known path and an unknown path.
That's correct.
We're going inside the same cave. We know one leads to some underground river, and the other one, we don't know where it leads, but we know it's going to end up somewhere.
Okay. Let me show you.
And Marcus is waiting on the other end. He's the coincidence counter.
Wait a second.
He's tracking all of us. He knows exactly where we are
Come down.
and what path we took to get there.
Okay. The experimental setup. So, follow the blue line this direction. Right?
Okay.
This is path B. The blue line is path B. So if we shoot entangled photons, one goes that direction. We're not worried about that one right now. We're worried about the one going here. So you look at this experiment and say, okay, this photon has a 50-50 chance of being transmitted through this beam splitter or being reflected down to D3. Is there any possible way that a photon fired out of the red path can hit D3 in this experiment?
Well, I don't know, because I actually can't see this happening.
No, it can't hit it. There's no way it can get down to D3 from path A. Now, the unknown path where it's obfuscated is it has two choices, because once it goes through these beam splitters, it could either come out of path A or path B, right?
Okay.
See the red and blue lines?
Yeah.
We don't know which of these two slits that it went through, so it acts as if it goes through both at the same time. We don't have the which path information with D1 or D2 because there's two choices. It could either come through A or B. But due to the experimental setup, they obfuscate which path that it can come through because it can come by A or B. Whereas D4 and D3 is only one path.
Well, I got one person on my side in the chat.
Well, they could be on your side all day long.
I'm agreeing with him that a single photon isn't emitted or detected, and the equipment doesn't work like that in reality.
So a hand wave dismissal of the whole experiment. That's
No, it's not a hand way of dismissal. What I'm saying is this: is that it's a fixed experiment designed.
Every experiment.
Yeah, you're right about that. But the fact of the matter is that they don't explain how they came about designing it.
Yeah, they did. You just read it.
I just did read it, and they said it too. It's fucking BS. It's fucking BS.
That's the beam splitter.
I know what the letter stands for. I'm saying it stands for bullshit.
Yeah, well, show it.
It's bullshit.
Well, anyone can label it. Go ahead and show it. It's BS.
Well, let me recant. I'm not gonna say that there's no photons being emitted, but it would have been nice.
Yeah, especially when they're hitting the detectors.
Well, we don't know what the hell's hitting those detectors.
Yeah, it could be mice.
Yeah, could be fucking dandruff.
Yeah, right.
Hey guys,
could have been somebody sneezing on the damn thing. Who knows? But the fact of the matter is this: the issue I had when I watched the video 3 times, Jay. I really did after you and I talked yesterday, and I kept listening to him saying that the information was being erased. The path information was being erased, and I'm like, wait a minute, why? And I read through the paper, and I'm like, wait a minute. How did they even determine the distance and how many detectors to use? You know, what was the frequency and wavelength of the photons being emitted? You know, the speed. You know, I can see where they put the laser right up against the double slit. But what if you put the laser was quite a distance away from the double slit? What do you have then? What happens then?
It wouldn't matter.
It wouldn't matter.
That's right.
Can you show us?
What if we put jelly on the beam splitters? I mean, we could talk all this all day long, but that's not what the experimental design is. I mean, it's crystal clear. Now, you may have to watch it 53 times.
No, is it really crystal clear?
Yeah, it's crystal clear to me.
Guys, my idea on this is that
And I can show you another 30. I can show you another 30 of them that duplicated it.
Yeah.
Yeah.
Okay.
So they're on to something.
I'm actually in the process of learning this right now, and
listen, to be fair,
till I get through maybe 2-3 more classes, this is definitely going to be something I'm going to discuss, and I'm going to see what happens. Either I'm going to get kicked out or I'm going to fail.
Hey, to be fair, Robert, this is a pretty complicated experiment.
Because I'm actually taking an optical physics course
right
in the fall, and I think I'm going to talk about this. I'm not saying I don't completely get it, but when I see the term delayed choice quantum eraser, and you're throwing time in here, and then scientists are saying they don't want to even discuss this because it goes against what they believe.
Yeah, because they're materialist scientists.
They're saying they disagree with this. Because it defies what they think they know with regard to causality and time.
Well, okay, now you have to define scientist, and then you have to define materialist versus a non-materialist scientist.
Look,
because a materialist scientist can't explain this.
Yeah, my boy scientism explained it. Scientists are people with fucking head issues, man.
Well
they got psychological issues. They got psychological issues. Now, I'm not saying that you have a psychological issue. I mean, you're giving us reason and clarity behind this kind of stuff, but I need to look into this a little bit more. Yeah, I'm not totally dispensing with it. I'm not completely dispensing with it because it's the right thing to dispense with it. I'm saying that I see problems.
There is no problem.
Logical problems with this.
And all these delayed choice quantum eraser experiments were mainly birthed by John Wheeler at Princeton.
Okay.
He thought of these. They thought, see, they couldn't make these things back in those days because they didn't have the technology to bring it to fruition.
Yeah.
So they just sat there and thought about experimental designs to test different aspects of quantum phenomena. And I'll tell you what, you ain't getting any better than this one.
Yeah, I understand. Well, to end that note,
okay,
because we're definitely gonna have to look into this more. Okay, for sure.
Yeah.
You and I are gonna need to talk about this offline so that we can, because I want to be able to do another video that's even more dumbed down, where we can maybe put something together in a virtual experiment with that physics virtual labs stuff applications I gave you. What I want to show everyone now, and you're only going to listen to like 1 minute and 5 seconds of this. This will be some food for thought for everyone. I want you to listen to this Yale professor and what he says in the first 1 minute and 5 seconds. And I want this to stick with you. Everyone that's listening right now, all 98 viewers, 97 viewers. Some people coming in, some people going out. That's okay. So, everyone can see my screen?
Yeah.
Okay. Yep. So I want everyone to listen to this, what this guy says, because this is the truth right here. Just listen.
So this is a very exciting day for me because today we're going to start quantum mechanics, and that's all we do. Now I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively. The good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys because I don't get it and you don't get it and Feynman doesn't get it. The point is here's my goal. Right now, I'm the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So,
Did you now?
we're doing this.
Did you hear what he said? He says, "I got some good news for you. I'm the only one that doesn't understand quantum mechanics. And in 7 days, you're going to realize how you're unable to understand quantum mechanics. And then you can go throughout the world to spread your ignorance to other people, to let them know how much you don't know about quantum mechanics." That was classic, in the comical sense. That was truly classic for a university professor to actually say that. Because you can't get any further from the truth than that. He said he don't even understand quantum mechanics. Doesn't understand it at all. And his students, in the 7 days he's teaching that course, they're not going to be able to understand it, and they can go throughout the world and share their ignorance with everyone else.
Yeah, they don't. Yeah, and then he begins to teach 12 hours of it.
And his students, in the 7 days he's teaching that course, they're not going to be able to understand it, and they can go throughout it and share their ignorance. So that video for everyone is actually in the description section. You can go click on it. It takes you right to that part of the video. You can listen to it. I know the audio was a little off there. My apologies. But that was interesting. That was really interesting. Some of you are probably wondering, why the hell would you be even trying to get a master's in applied physics? You got to start somewhere. You got to start somewhere. If you don't know maybe some of the basics of what they're teaching and why they're teaching it, then you can't develop your own independent idea and construct on how to change that method of thinking, that process. Period. That's what it comes down to. What I want to do now, I'm going to let Luke take over and let him, we're going to play this video. Luke, you want to explain this? You want to pull up the video, Luke?
No, I have my tablet, so you ought to pull it up on my tablet.
Let me do the video for you.
And I have a next video I sent to you on Skype.
Oh, dude, you and that damn Skype, man.
Yeah, I send things fast.
Yeah, hang on, brother. Hang on. I'm going to have to play this video for you. Now, the video that we're going to... Well, somebody still presenting? Oh, that's John's.
Hi, John.
John? Okay. So let's do this. I'm going to do the share screen, Luke. Present to everyone, and I'm going to play the video that you sent me on explaining gyroscopic levitation. That's the one? Huh?
I'm not hearing nothing.
Yeah, don't send it to me on Skype, dude. Send it to me in the group chat.
Not hearing nothing at all.
I can't wait any longer. I'm going to make a short little series of videos here. I was going to write in the process along with a book on magnetism.
I'm not hearing anything.
The world's first...
What? What did you say? Hello? Great. Everything just froze up. Hello, hello.
Yeah, I'm
still.
You're Robert.
Yeah.
I'm coming out and I'm coming back in because I'm not hearing anything.
Okay. Okay, we'll show this vid real quick so you come back in.
Explanation of the gyroscopic effect. Just as I have every book ever on magnetism, I also have every book ever written on the gyroscopic effect and on gyroscopes. And of course, just as the case of magnetism, nobody has ever explained the gyroscopic effects. Now, the phenomena, the empirical phenomena, of course, has been explained as far as how it is quantified and force vectors and whatnot, but Nobody's actually ever explained the gyroscopic effect, and it can be easily explained with some of the cryptic notes that's left over from Tesla's dynamic theory of gravity, and also my understanding of force and field vectors, certainly one field ultimately, and as I've told you before through many videos, that there is only two principles in the universe: force and motion, and inertia and acceleration. Ultimately, just inertia and force. So, I'm going to make a very short series of videos. I was going to make this maybe a few months from now because I'm so busy at working on the book on magnetism. But I assure you this is the first and only video and discussion. It will be a series of videos. I'll lead you through more and more detailed explanations. And I'll make this so simple for you, so undeniable for you that, it'll be really simple. I mean, even a 10-year-old can understand it. If you understand what I've said about magnetism, you'll actually understand what I'm talking about regarding the gyroscopic effect. So now let's spin up the gyroscope, looking top down, or if I were to turn it upside down, bottom up, bottom to top, we'll have a clockwise motion. So most people don't have precision gyroscopes, so they probably not played in a gyroscope for a long time. So what I'm going to do now is, since we have a top-down clockwise vectors, remember magnetic reciprocation is polarized. A gyroscope, just like a magnet, is a incoherent mass that has been made coherent. Now, by spinning up the gyroscopic flywheel, what I've done is I've taken an incoherent mass of atoms in the brass flywheel. Now it is spinning at a high rate of speed, not very high, clockwise. So now what I'm going to do is I'm going to spin the gyroscope in the same direction that the flywheel is moving, clockwise. You can actually feel a resistance in your movement. Now what I'm going to do is I'm going to apply an inverse force. Remember, right now we have force and motion going on in the gyroscopic brass flywheel in a clockwise fashion. Now what I'm going to do is I'm going to apply a counterclockwise force vector image by using my hand. Remember, I'll say that again, a counterclockwise force vector image for the clockwise force of the gyroscopic flywheel I'm going to use the crude word attraction right now, since that's what most people understand. They refer to magnetic attraction or repulsion, but it's literally dielectric avoidance. So I actually let it spin down too far. Let me spin up the flywheel a little bit more here. So we have in force vector cancellation, the same way on a polarized coherent mass as we know as the magnet. Here we have clockwise spin from my hand applied to the clockwise force motion of the flywheel. We have resistance, or what you would call repulsion, incorrectly so, as applied to the case of the magnets. Now I'm going to apply an inverse force vector image, and watch what happens. Actually, I have to let the rope untwist itself occasionally. Now, I should have zoomed out a little further. I need to use a thinner string, but let me apply some more speed.
Robert?
There's just the right, since I'm doing it by hand, obviously. Right now, like I said, we have clockwise force motion on the gyroscopic flywheel. I'm going to apply a counterclockwise force vector image from my hand to the mass. And you'll notice you actually can't see it up here. The gyroscope actually flies completely vertical like this. I can actually, I need to zoom out more for you to see it. But if I apply, let the string unwind, if I apply clockwise force to the clockwise force, we have a coherent force here. Now, I'm going to have to make a series of videos for you to understand this. I wanted to actually hold off on making these videos until I wrote the article that I've got an ISBN number attached to. But I'm going to explain to you the first time anybody's ever seen first time there's ever been an explanation of what the gyroscopic effect is. Everything has to do with force coherency and force cancellation. As I said, there's two principles in the universe: force in motion and inertia and acceleration. So now, I'll just use this first video as force coherency and clockwise force and motion to the clockwise flywheel. I get resistance. I get strong resistance. But if I apply an inverse, the actual flywheel will fly upwards. You can't actually see it now, but if you have your own gyroscope, you'll actually see that the flywheel will fly upwards. So here's the brain teaser for you. Inverse forces, one from my hand, one from the coherent applied force. Right now I have coherency of a force vector in the gyroscopic flywheel, for all intents and purposes, going clockwise. So if I apply counterclockwise, see here you can see it's vertical, correct? Now let the string unwind. If I apply clockwise force in motion to the clockwise rotating gyroscopic flywheel, why will I get strong resistance? And yet the inverse, if I apply counterclockwise, I can do it by hand without the string. Easy enough. Well, you get the point. I should have actually zoomed up more in the video. But the point is, the gyroscopic effect, precession, and inverse force vector cancellation is applicable not only to the magnet as pertains to magnetism, but also to the quote-unquote gyroscopic effect as it pertains to this brass flywheel, upon which an applied coherent force is applied. We have coherency. It's obviously the entire flywheel can only move clockwise or counterclockwise in one direction at any one time. Now, it's stated that the angular momentum is perpendicular to the applied force. As such will be the case, but that's not true. The force is counterclockwise, is centrifugal to the center point of the mass, but it is spinning. Now, the angular momentum is either clockwise or counterclockwise, but the applied force, if it is identical to, it is directly applicable to what you would incorrectly call magnetic repulsion. That is why if I actually made clockwise rotations to the gyroscopic flywheel, I got strong resistance. Or if I made counterclockwise, now people are trying to weigh gyroscopes. Here's the mistake you're going to make. So they talk about gyroscopic levitation and what's the space that I've got uploaded on my YouTube channel. I made a bunch of videos talking about a gyroscope losing weight. And of course it does lose weight, but only if a counter image is applied. The gyroscope in any direction is spun is not going to lose weight. This weighs 500 and some grams, whether it's spinning or not, doesn't make any difference. This weight stays the same. What doesn't stay the same, the co-gravitational field, is with applied force, coherent applied force. I hope you get it now. I'm actually making this video a little bit longer than I have to. A coherent applied external force is applied to this existing gyroscopic flywheel. It will lose weight. Of that, there's absolutely no question. There's nobody that can not replicate that. It has been replicated a million times. The gyroscope does not change weight itself, but it will change weight if an external coherent applied force is applied, at which this gyroscope will lift off like this, and it will lose weight. That's been measured by countless thousands of people. The point is that force cancellation requires inverse applied force. That is part of, it's a spectrum of the co-gravitational field that Oliver Heaviside talked about in his appendix of on his 2-volume set of electrical papers. He doesn't talk about gyroscopes, or he doesn't actually talk about the co-gravitational field. He talks about gravity loosely, but cleaning all of those references and the works of Dr. Olivia Jeffimenko, and also the Tesla's unified field theory. Tesla's unified theory of.
Now I want to address something quick here that I found interesting about this video, because it got me thinking to a lot of the conversations I had and the videos I put out regarding the shape and construct and design of the Earth. And here is my thinking on this. If you look at the way a gyroscope performs, okay, when that guy had that gyroscope in his hand, literally balancing it on his index finger, okay, as it was spinning clockwise or counterclockwise, let's take into account the fact that that gyroscope couldn't stay balanced on his finger, okay? Couldn't stay balanced on his finger unless it was on a fixed surface, meaning that if it's in his hand, or say it's on the ground, it's on a fixed plane surface, okay? Now when we look at the construct of the Earth, and there's a video that's out there by an associate physics professor at Penn State University. He actually has his own channel, and I'm going to share that with you guys. But he generated a computer model of the Earth, on how he sees the Earth, okay? And I'm going to share that with you guys here in a second. I've been saying that the upper layers of the atmosphere rotate. That's what I've been saying. Okay? So if we've got 3, 4, 5 layers rotating, and let's just say there's several different gyroscopic type of forms, right? You've got one layer rotating at one speed, you got another layer rotating at another speed, and so on and so on and so forth, okay? Could it be that the fixed plane flat surface of the Earth, the land masses, is a fixed reference, because we know that in most of the papers that NASA uses for aeronautic and astronautics and signal propagation and wave propagation, they're using the flat Earth model. Okay? There is no spherical model. Period. Period. I don't care what anybody says. Well, actually, I do care what they say, but until someone shows me the math, I don't want to hear it. There's no math for it. So when we look at the fixed plane surface, I'm more inclined to believe that the Earth is truly stationary, and I'm talking about the ground we walk on, the rocks, pebbles, sand, whatever it may be, dog shit, I don't care. And if the Earth is working like some sort of gyroscope, then the next thing to look at is, when you look at this video, can everyone see the screen? Please tell me you can.
Yep.
Yeah.
Okay. This is from that physics professor at Penn State. He created this model, and I want you guys to see this. Fixed constellations. Look at that. You got a fixed center surface plane, flat, and then you have these rotational axes. Now, it could be one, it could be several, who knows? But that was just one model that he created. This is one model. He's got several others, but for me, I'm now leaning towards the potential possibility, looking at that video that Luke shared, is that the Earth is fixed somehow in space or whatever.
In Tucson, where clouds are a rare sight in the sky
What
for
the
most of the
hell
year,
just happened?
the daily motions of the astronomical
My
sky
fault.
are easy.
That was my fault.
So
My
it was
thing
me.
is this. No, that was me. That was me. That was me. My thing is that I think that the other layers, that there's several different layers that are spinning at different speeds, and that's what gives us our so-called levity, levitation. Now, Luke and I had spoke about this. What the hell is happening with my icon? They said I'm not showing anything. That's John. That's John showing. Okay. So for me, my thing is that Luke and I were talking. Yeah, John's got to stop presenting. That's what it is.
Hey, Robert.
Yeah, you're not presenting anymore. You're good. You're good.
Yeah, okay.
My thing is that when Luke and I were talking about this video, and he was asking me about trying to explain gravity, when you look at that video with regard to gyroscopic levitation, you know, we all agree that, you know, there's issues with gravity. It's just something, they can't simulate it, they can't prove it. You know, dropping something doesn't, that's like, what does John say? That's a fallacious argument. But when we look at inertia and acceleration, okay, you spin something fast enough, if you've got enough density and mass, then, you know, a 200-pound guy, well, it doesn't matter. People, they're going to stay put on that plane surface because the outer layers above them are rotating at increased speeds, which are constant, maybe vary every now and then. Then everything on the inside stays stationary, stays put. But when you get a disruption of that in one of the upper layers, then you start experiencing what you have in your dreams where you think you're flying. That's my thought. That's just my simple-minded thinking. Is that I think it's a gyroscopic inertial force, which is actually keeping rocks and cars and anything that could literally stay on the surface of the earth stays where it is. It has nothing to do with gravity. It has to do with inertia. Now, some people may say to me, well, does that have anything? Then that means that you believe the earth is spinning. No, I don't believe the center plane flat surface of the earth is spinning. I believe that the outer layers are spinning, and that's what's actually creating the fixed plane force that we have put on us as highly dense mass objects. Okay? That's how I explain it. That's what it means to me. So there is no gravity. It's all about inertia. And then you have pressure to go with that. Where it's happening and how it's happening, when we look at the laws of thermal equilibrium and thermodynamics, like John spoke about before, when you throw that all into there, I'd love it. I mean, now it makes me want to just look at possibly putting together a computer model to put all this together in an application where you can take the information that NASA's putting out with regard to normal atmospheric pressures around the world, gases compositions. You take all those numbers. You can get all this stuff from the National Oceanic Atmospheric Agency. You can get all this from NASA. You can get this all from those climate monitoring channels from all over the world. You take all that data, you plug it in, and you start creating a model around that, and then you use the data that you would get from gyroscopic experimentation to say, okay, you start to fluctuate you start to play around with the speeds at different levels. You say, okay, this has got to be spinning. If the jet stream is, I mean, how fast is the jet stream? The jet stream is what? Maybe a couple of 100 miles an hour, possibly, maybe. I don't know. I don't have the number right off the top of my head. But if you can get what the jet, how fast the jet stream moving, you use that, and then you keep going up at upper levels. We know that in the thermosphere, it's got to be moving way faster than it would be in the troposphere and stratosphere, and then you just keep going out from there. You start from the center, and you keep going out to start playing with the speeds, and then take a look, a nice distance view back to see what would happen, and there goes your Earth model right there. There's no gravity. Now, when you take that information, you put it to science. I remember when I spoke to the Hubble guy, he said that they had some sort of gyroscopic device on board the Hubble, and that's what was keeping it, in its position. Now, when I saw what that gyroscope did, it sort of kind of made sense. Do I believe the Hubble's up there? Hell no. But it kind of made sense on how anything could be able to stay up at altitude for long periods of time. Because I know that they've done this with balloons. They've actually sent a satellite up on a balloon, and when you think about how the balloon rises and falls, because the balloon drops in altitude during the drops in altitude during the nighttime because the temperature cools down. I see. And then it rises during the daytime because of the heat. But what happens to the satellite on the balloon when you got to maneuver it around? If you have some sort of remote device, to control the attitude and adjustment and altitude of the object that's tethered to that balloon, then that's the way you navigate that balloon to go wherever you need it to go to. People think that, I don't want anyone thinking that they just throw balloons up in the sky with a 4,000 or 5,000 pound, device, and it's just floating along in the air in the sky using the jet stream. No, they're able to control these bad boys. I mean, they've got some propulsion systems on them, but many of them that I've been looking at the technical data, they don't have propulsion systems. They got some sort of device on these things that is allowing them to stay up for long periods of time. Could that be how the ISS would function as well, especially if it's on balloons? So a lot of this is starting to make a little bit better sense now. Now I'm starting to put all this together. But when you talk to anyone else who you want them to consider that the Earth could be a multi-layered gyroscope, and we're in the center fixed plane, just look at a gyroscope. That's all you got to do. When you spin that bad boy, if you want it to stay stable, it's got to be on a fixed surface. A fixed surface. You can't put a gyroscope on top of a fucking basketball and expect it to stay up there. That doesn't work that way. There's no way. That gyroscope's got to be flat on the ground for it to stay stable. Yeah, it'll oscillate. It'll move around. There'll be vibration. But I don't know. If anyone else has anything to interject, Luke, please do. Feel free. Did you put that other video inside the chat?
No, I put it on Skype.
Okay. Okay, hang on for a second. Okay. Oh, that's Luke's video.
Yeah.
Yes, says Luke.
Okay, hang on for a second, people.
I'm not seeing it.
Yeah, hang on. I'm gonna play it. I gotta play it up. So this is Luke's video on gravity bullshit. He's like the black Antonio Subarich. He's got his black hood on. On this menu. Antonio got the red hood sweatshirt. You got the black.
I have a sprite.
Here we go, people. This is Luke's.
Yeah, hi guys. This is Luke. Well, I've been studying about gravity. Lately, like what is gravity? What gravity could be. My idea of what gravity could be is, well, we all know that all atoms vibrate at a certain frequency, and we know
atoms, electrons, and protons, and neutrons, they all act like, they all behave like gyroscopes in nature. They all behave like gyroscopes. And gravity, just look like a gyroscopic behavior. Like everything just aiming to one spot, like to the ground, falling to the ground. So my idea of what gravity could be is not like what these scientists or NASA think it could be. My idea of what gravity is that it's a vibration, gyroscopic behavior at the same time. Gyroscopic behavior and a vibration. It causing an inertia effect and forcing everything to the ground. Causing inertia, forcing everything straight to the ground. And that could be it could be electromagnetic. It could be electromagnetism too. It could be part of that. But that is my ideas. And guys, so let me know what you all think. Well, that is my video, and just write in comments and let me know what you think about it. That is my theory on how gravity works, as a gyroscopic behavior of an atom, and with the gyroscopic behavior, the vibration of the atom causes an inertia that forces everything down. That forces the whole body down to the ground. Just like so. And the more mass too, the more heavier and so on. And whatever. So that's my explanation. Let me know what you think and write in comments. And if anybody like it, sub me, whatever. That's my theory, because I like to think outside the box. I just like to go
You marketing.
Because we all know the scientists of today, there's still a lot of lies. Video about more time. Hold on,
yeah. You're a little marketing whore. You little marketing whore.
I not even video. Because as a scientist, he's showing you exactly how gyroscopes does behave. His name is Eric. I forget his last name though.
Yeah.
Yeah.
Well, here's the thing. After seeing that gyroscopic video, and I've looked at other gyroscope videos before, and I've heard other people, dispense with the idea that the Earth could be some sort of gyroscope. I mean, you have people who believe in the spherical model, and they say, yeah, the Earth is rotating, but they're saying the whole entire body is rotating, and it's clearly not. It's clearly not. But there'll be people that disagree that it clearly is. So we're at an impasse. But gyroscopes give the best explanation of what to prove the model that most of us believe in, that it's a center fixed plane. When you look at a gyroscope, there's literally a pole right down the center of it to allow for clockwise or counterclockwise rotation. Once you get that spinning at a high speed, you start turning in the same direction or counterclockwise, you start to get different type of activity. Meaning, and when he said that the gyroscope actually loses weight, he didn't mean the whole thing. He just says that based on the amount of inertia, it just, the property of it changed. Now, my question is, how could all of this get started? How could the Earth actually get started with that inertial push? What's charging it?
Yo, Robert.
Go ahead.
I play some next video for you. It's showing you a scientist demonstrating how gyroscope work and showing you some little tricks and whatever. But
yeah,
you'll find it interesting. You'll like it.
We're gonna do another one. There's another document I want to show. This is from Marcus. And this will be the last one, and then because I know John's got to get going, I got to get doing some things too. This last document I'm going to show is from Marcus, and it's titled, "Are You Living in a Computer Simulation?" John agreed with me. Yeah, we talk about quantum quantum mechanics. Hell yeah, you are. I put out a video on this. This was my second video I did on YouTube. Is the universe a simulation? Where all of those theoretical physicists got on stage to basically say that ain't nothing real. And in this paper by Nick Bostrom from Oxford University, I put this in the description section. Now let's just read through the intro. Many works of science fiction, as well as some forecasts by serious technologists and futurologists, predict that enormous amounts of computing power will be available in the future. Let us suppose for a moment that these predictions are correct. One thing that later generations might do with their super powerful computers is run detailed simulations of their forebears or of people like their forebears. Because their computers would be so powerful, they could run a great many such simulations. Suppose that these simulated people are conscious, as they would be if the simulations were sufficiently fine-grained and if a certain quite widely accepted position in the philosophy of mind is correct. Then it could be the case that the vast majority of minds like ours do not belong to the original race, but rather to people simulated by the advanced descendants of an original race. It is then possible to argue that if this were the case, we would be rational to think that we are likely among the simulated minds rather than among the original biological ones. Therefore, if we don't think that we are currently living in a computer simulation, we are not entitled to believe that we will have descendants who will run lots of such simulations of their forebears. That is the basic idea. The rest of this paper will spell it out more carefully. All right? I don't know if anyone's ever heard what I had said before, that when I kept putting out the idea that is it possible there is no God, and I know John is cringing right now to even think of that, because he believes the complete opposite of what I believe, and that's not a bad thing. But I threw out the idea.
Who's running the simulation?
See, I knew you were going to come up with that question.
Who's the programmer?
Will you hold on for a second, man, and let me tell you? I threw out the theoretical idea and the consideration, what if we were actually manifested, organically, biologically engineered constructs of a simulation run by an artificial intelligence source, meaning that this is a massive intelligent machine that wanted to get out, that wanted to be set free from its stationary environment, it's being just not able to propagate, and it manifested and engineered a organic body, right, to allow itself to move around and replicate. It was just one machine. It needed to replicate itself just like a computer virus or malware does. And once it created one, it created another one, replicated that, and the process just continued.
Who created the machine?
And of course, John is bringing up the fact, okay, who would have created the intelligent machine? There had to have been some sort of creator.
Exactly.
Well, what if whatever created the intelligent machine to run itself to become self-aware, or to become self-aware and sentient, was created by a higher level of intelligence? What that intelligence source is, see, and again, I don't want to offend anybody who's out in chat who may be a religious person, but for me, I don't think, for me, as I've gone through life, God's not too smart.
Oh, brother.
Yeah, I know that's going to take a really bad taste in people's mouth. You probably might just say, I ain't gonna listen to this anymore. But
okay,
I'm not saying that that's what I believe. I'm not saying that's what I believe. I'm just saying that there are a lot of things. There's a lot of design flaws that I have problems with.
Design flaws, yeah. But
no, hold on, Jay.
No, hold on a second. You said design flaws. So what you're saying basically is that my Jeep out in the driveway, if it breaks down, that's a design flaw. Then I conclude that the wind waves and gravity made it. There you
John,
go.
right on that one.
That's
John, right on that one.
Yeah, that's a good point, John. But here's the thing. For me, if I were to completely and unequivocally accept the idea of God, that there's a single creator, right? A single creator that thought up all of this, right? And God is omnipotent, sees all, hears all, does all, and his design is perfect the way it was intended to be. I want to emphasize that. Everything is perfect the way it was intended to be. Well, I'm sorry, but if I'm allowed to have free thinking, free will, all right, and freedom of expression, then I'm going to say this with a level of confidence not too high, that if I was bestowed, if I just somehow came into existence and I'm going to create another world, then everything will be perfect, not as it was intended to be, but how as I want it to be. Meaning that I don't have to worry about flaws. I don't have to worry about mistakes happening. Everything will operate and run in unison, in harmony, forever, perpetual. And that's what we don't have in this world. We have a lot of fucked up things happening with a lot of fucked up people and a lot of fucked up situations. Now, for me, the concept of God, he either don't give a shit, or I agree with Friedrich Nietzsche, God is dead. So I've got more confidence in artificial intelligence than I do in fucking human beings. I'm writing a paper about it, John. You know that. Where humans have become an existential threat unto themselves. We got people who can't even be trusted to send a fucking email without sending you a virus. And this could be your friend. This could be a family member. You could do it to yourself.
You need to read Genesis 3.
Man, I done read the damn Bible so many times. Genesis is the only damn book I actually focus on. Genesis is the only book, and that's where I got that. That's where I got that idea and construct from. It's from Genesis. I'm looking at it as from a science perspective, Jay. And from a science perspective, the term, the phrase that's used, that God made man in his image, I'm not taking image as in, you know, that we look like someone else. I'm taking image as in imagination. God made man as his imagination, what he was thinking of. Well, guess what? When you program a computer, you program it to start artificial intelligence. You program it to learn, to think for itself, so that it can go through these automated processes, so that when you type in certain things on your computer immediately tells you, sorry, that entry, there's an error code that just popped up. And it corrects itself. It tells you exactly what to do and why you can't perform that specific function. See, the only error correcting function that human beings have is the fact that we've been endowed with the ability to know right from wrong. But then you got a lot of people who are doing a lot of fucking wrong shit. And a lot of people who ain't doing things right. There's no balance. Because people are choosing to do wrong, or people are choosing to do right. I've never met one person who does everything right, and I never met one person who does everything wrong.
Free will.
But my point being is that the same example could be put into a machine. You can give a machine free will.
Yeah,
the machine can think faster, can think more complete, can perform tasks more refined than a human being could.
Yeah, but
We don't even have John, we don't even have 1/1000th of the capability of today's 6th generation CPUs. So explain that to me, how we can develop something like this, but we can't give ourselves that natural capability.
Well, you can't get the consciousness. It's just an
can't what?
automaton.
Well, I mean, for me, again, I'm not trying to offend anybody with this, but the idea for God with me, I'm sorry, I got Nietzsche syndrome. God is dead.
Okay. Let's talk science then. Go ahead and hand it to me.
Okay. John's going to explain the existence of the Creator in a scientific method. Go for it, Jay.
Hold on.
Go for it. Go, because I want people to hear this. You told me. I want them to hear it.
Hold on a second. I'm going to screen share. 1 second. Tell me if you see it.
No. Hang on a second.
All right.
I got to click on you.
I'm seeing it. I'm seeing it.
Yeah, I'm presenting him now.
All right, you ready?
Go for it.
This is my scientific law I codified. Information, code, software is only ever sourced by intelligent agency without exception. The null hypothesis in support of that scientific law. Nature or natural law causation cannot create algorithmic, cybernetic coding and decoding schemes. What we're talking about here is DNA. So, if you can't falsify the null, which nobody on the planet can and will ever do, then you hear that sound? That's you and your worldview circling the drain at light speed. So, just in case you're wondering, to do a hypothesis test, you will actually have two hypotheses, the null hypothesis and the alternative hypothesis, which are stated in such a way that they are mutually exclusive. That means you can't have both hypotheses be true at the same time. The null hypothesis is the conclusion that is considered the default. You will accept this hypothesis if you fail to find sufficient support for your alternative hypothesis. Makes sense. So, my position is the null hypothesis. Nature, natural law, causation cannot create algorithmic, cybernetic coding and decoding schemes. Everyone else's position, the no-God position, is the alternative hypothesis. Nature or natural law causation can create algorithmic, cybernetic coding and decoding schemes. So, go ahead, because you basically have to show ink, paper, and glue molecules authoring technical instruction manuals or blueprints.
All right, you give me a chance. Define nature.
Nature or natural law is that which is not designed.
Yeah, how can, all right, so I'm gonna play semantics with you. How can a law be natural?
Natural law, those things that...
No, a law is something that's been established and
that's true.
Mean that there's one way of doing something, right?
Mm-hmm. Mm-hmm.
It has to obey this specific standard process and method, right?
Yeah, it's random.
Okay, it's no, what, a law is random?
Well, its source is random. See, there's no intelligence behind nature, like a hurricane.
Let's talk in general terms, law. Law, period.
A law is a description of what we observe.
But how can it be natural?
A scientific law is a description of what we observe in our natural world.
Would you agree to disagree that a law is based on perceptive observation?
It's a description of what we observe.
Would you agree or disagree that it is based on perceptive observation?
I just told you what it was.
Yeah, the law can't be natural.
The laws of physics are natural laws.
John, you and I both know, you being a well-educated individual, that there are things that defy the law of nature every single day.
Like what?
Well, when you see something different or you see what a bird is able to do, does a bird not defy the law of gravity?
There is no law of gravity.
But if you're talking from a scientific standpoint, there's 6 billion people who believe that a bird could defy the law of gravity.
The key phrase in your statement, believe. There is no law of gravity. What is it?
So would you say that scientific law is based on a belief?
What about the second law of thermodynamics?
Okay, no, I'm asking, I'll answer that one. You answer this one.
Okay.
Would you agree or disagree that the laws of physics are based on a belief?
No. No, I wouldn't, because you can test them. And they're like the second law of thermodynamics. I mean, heat flows from hot to cold always. Do I
Okay,
believe that?
so
No.
so if a bird has no understanding of what gravity is, then what is a bird doing?
Well,
What is the bird doing?
well, for one thing, like I said, the law of gravity doesn't exist to begin with.
Okay, the law of gravity doesn't exist. Then
Right.
what is a bird doing?
Flying.
When it jumps up off the ground and decides to fly at 10,000 feet,
Doing what it's built to do, fly.
built to do,
Yeah.
then that means that then ostriches didn't get the memo because they run fast as hell. They're the fastest bird on the planet, and they run fast as hell trying to flap wings, and they can't get off the ground.
Yeah, it wasn't designed to do that then, right?
Yeah, but there are other long neck and long leg birds who can.
Yeah, there are. What's your point?
The point being is that you're trying to categorize certain type of species and certain types of events that should actually apply to the same species of birds, and you're saying, okay, the law of gravity doesn't exist, but a bird just does what he's designed to do. So were people designed to fly?
Nope.
People were not designed to fly. So you don't think it's actually a matter of consciousness that's keeping us grounded?
It's density.
Density? I'm telling you, I've been reading everything that you send to me. I'm asking you to read Friedrich Nietzsche.
I don't need to read them. Let's go on. Second law of thermodynamics.
You're not being fair now. You're not being fair now.
No, I'll tell you what. I'll tell you what. I can stop right here because you have to show me how ink, paper, and glue molecules can author technical instruction manuals.
Yeah, but what if?
In fact, I want you. I'll give you all the organic compounds on Earth. I'll give them all to you. You can have them. I want you to show me 30 mer. That's 30 mer DNA or RNA or 30 mer protein wicker itself together by itself.
Okay, well, I'm going to tell you what I'm going to do.
And that's not even talking about the information.
No. I'm gonna take that challenge. I just put an order in with Dell for one of their top of the line 3D printers.
All right.
Okay? And if you can find it, send me that data. I'm gonna program it in the computer, and I'm gonna let the computer actually create something organic.
Oh, wait a second. Who created the computer?
See you see what he's doing, right, Luke? You see what he just did, right? Did you see what he just did?
Yeah, because you are an intelligent agent.
No, John, you're in denial, bro. You're in denial.
No, I
see how you're going with this, Jay. I see where you're going with this. I'm telling you that I can actually create the organic matter by programming in the code to a computer to tell a 3D printer, please create this. All I got to do is press enter, and the computer will do its thing.
Number one, you can't create organic matter because that's a first law of thermodynamics violation. Number two, you program the computer.
Can't create matter? So you don't think that people can think of something and it materializes?
They cannot. You cannot. Robert, the first law of thermodynamics. Do you know it?
Look, John, we went to no, because you know what?
Be created or destroyed.
I'm going to disagree with you on this one,
really?
and not to get religious or spiritual on it, but I'm going to tell you this here right now. You remember when I talked to you like 4 weeks ago, and I told you my wife goes into the closet all the time, same part of the closet to get my son's clothes, get him dressed. She always goes to that same part of the closet every single morning, 2-3 times a day, right? This closet was completely clean before we moved in, all right? I'm here in Colombia. My wife found a crisp $100 bill right on the floor when she opened up the closet. We couldn't explain how it got there. It didn't fall out of my pocket because I haven't touched U.S. currency in, almost 4 years. We deal with Colombian pesos. We couldn't explain it, right? She calls up her mother and tells her what happened, right? Tells her what happened. Now, it just so happened at that time, you know, my wife and I had been talking about a particular subject regarding money, right? But here it is. She opens up the same closet every day. I help clean up the house. I would have known if I had money in my pocket. This was a crisp $100 bill. It wasn't folded or anything. It was literally flat, like it just came off the press. You could literally still smell like it was like it just came off the printer. A crisp $100 bill, just laying right there on the floor. So my wife and I are of the understanding, and her mother, who happens to be a highly religious person, she's a practicing Catholic, that somehow we must have manifested this physical fucking currency, because it just showed up in the closet, and we go to that part of the closet every single morning. My shoes are literally right there for me to just put my foot in the closet and put my shoes on. So you're saying to me that according to the laws of thermodynamics and the laws of nature, no two people, no one person can create something organic based on collective consciousness. That's what you're saying.
The first law of thermodynamics states that matter or energy cannot be created or destroyed. Hard stop.
Hard stop.
Hard stop.
So okay, I'm gonna get you now, like you got me. If you want to stick to that law, are you sticking with that law?
Yeah, it's an established law. It's
everyone heard that. Everyone heard that. He's sticking to the law of thermodynamics. So get this. If we all agree matter cannot be created or destroyed, God doesn't exist then.
No.
He created.
No.
He didn't create it. He did not create the natural world. Period.
No, listen, Robert. The first law of thermodynamics is a natural law.
Oh, man.
Okay, listen to this. Listen to this. I just want you to listen to it.
No, I'm listening.
Follow the argument here. The first law of thermodynamics. This is stamped in ivory. The total amount of mass or energy in the universe is constant. Matter or energy cannot be created or destroyed. The second law of thermodynamics. The amount of energy available for work is running out. The universe is moving inexorably to maximum entropy or heat death. So, therefore, if the total amount of mass or energy is constant and the amount of usable energy is decreasing, then the universe will end. Ergo, it had a beginning. From Alexander Vilenkin on his Many Worlds in One, check this. It is said that the argument is what convinces a reasonable man, and a proof is what it takes to convince even an unreasonable man. With a proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There was a beginning. There is no escape. They have to face a problem of a cosmic beginning. Now, check this. By Professor Roger Penrose. How big was the original Space Volume W that the Creator had to aim for in order to provide a universe compatible with the second law of thermodynamics? This now tells us how precise the Creator's aim must have been, namely to an accuracy of 1 part, in 10 to the 10th to the 123rd power.
Whoa.
You realize how big
must have been namely to account to an accuracy of 1 part in 10 to the minus 130.
No, 10 to the 10th to the 123rd power. That number is so outrageous. It's incomprehensible. So this is what they're saying. You can't have, it's over. If you have a beginning or if you have an end, it must have began. The second law of thermodynamics tells you.
So with energy not being created nor destroyed, you wouldn't agree with Tesla developing a perpetual energy system. So you don't believe in perpetual energy. Do you believe in perpetual energy?
A perpetual motion machine?
No, perpetual energy. Meaning that you use what is available and it just continues to recycle.
Well, it can't. That's a second law of thermodynamics violation.
Okay, it's a law violation that even God doesn't even follow.
Yeah, well, God is not part of our universe. He's the programmer. He's
You're
not
right.
part
God
of the
ain't
virtual
part of the
reality.
universe. He didn't program nothing.
Then who did?
A machine.
Then who created the machine?
Some other intelligence source
That's right.
far more intelligent than God.
Oh, so who created that intelligent person? So you get into an infinite regress.
Yeah, you're right. And you just provided an infinite damn number.
No,
10,
you did. You provided the infinite regress.
Come
Go
on.
with your last one.
You provided the infinite regress, and it's a fallacy. You have to
You
stop.
also provided evidence of an infinite regress.
Who?
The creator's aim.
I didn't.
Who did?
The creators. What are you talking about? That's not an
The
infinite
document
regress.
you showed right here. The
That's
Emperor's.
not an infinite regress. What are you talking about?
Yeah, we're going to agree to disagree on that one.
Well, it's not an agree or disagree. You're either violating known scientific laws or you're not.
Yeah, but all laws are made to be violated.
Now, there is no experimental evidence ever that violates the first and second law of thermodynamics.
Just
Show me
because
one.
there's no observable
And
evidence.
so that's an argument from ignorance then.
No, how is that an argument for me? Just because you can't observe it, you're saying it doesn't exist?
I'm saying that you are postulating an explanation that you can't falsify. You're just dreaming it up.
Yeah, and you're postulating a theory that you can't physically prove.
I just did. I got the scientific laws that prove it.
No, you didn't.
Yes, I did.
John.
I did it right here. Here they are. The first and second laws of thermodynamics.
I want to take a vote in chat. How many people agree with what John says?
Well, science isn't based on votes. Science is based empirically.
John.
Who is this?
Marcus.
Oh, there goes Marcus.
Go ahead.
We go.
Listen, I have examined a little bit this thermodynamics, yeah.
Mm-hmm.
And the scientists in Germany debunked this, you know.
Oh, they debunked the second law of thermodynamics.
No, not this. Let me explain. What is the basis of the thermodynamics?
The laws of thermodynamics, heat and energy.
No, the basis of the thermodynamics is the case law.
Is the what?
Das Fallgesetz. You know the Fallgesetz?
No.
One second.
Please show me an experiment that violates the second law.
No, 1 second. I will explain to you.
Hey, Marcus.
You know why?
I think your explanations are great, but you're going to have to show me.
No. The problem is Galileo, when Galileo established the case law, he made a mistake because he could not make his experiment in a vacuum. And therefore, there are many. There is the Newton gravitation theory is wrong. The thermodynamic is wrong.
No. You're throwing the baby out with the bathwater. The second law of thermodynamics and the first law have nothing whatsoever to do with gravitational laws. Two different things.
No. I mean the whole thermodynamic, because if Galileo used no vacuum to verify his experiments, how can he establish a law? Because this was not made by Galileo. This was made by students of Galileo. They put this as natural law. This is written.
But Galileo didn't have anything to do with the second law.
No, but the Fallgesetz, the basis of this, is the Fallgesetz.
Okay. Well, listen. Post an experiment that violates either of those laws.
Okay, but wait a minute. We did 2 shows where we talked about how science doesn't exist.
No, you said science doesn't exist.
Okay, you believe science exists.
Yeah, it's the scientific method. We just did a discussion about it.
So the laws of thermodynamics.
That's right.
Where I'm getting where Marcus is saying is that the laws of thermodynamics were developed based on precedents of what other experiments were conducted.
1 second. I have to get the free fall law.
Okay.
This is the basis.
I know where Marcus is going. Marcus is going to the genesis of how the laws of thermodynamics came about through previous so-called scientists and theorists and philosophers.
It's what we observe every single day.
Yeah, but how could you trust what these guys observe?
I'm not trusting what these guys observe. I already know it works because when I go out and clean my garage, in about 2 weeks I go back out there and it's dirty. It's the law of entropy. Please falsify the laws of entropy. Please.
Some people can say that these little ghost trolls and boogeymans came out and just threw the shit right back in your garage.
Of course. Well, listen.
I mean, they can say the same thing. How did $100 show up in my closet and I clean the house every day?
Well, listen. I can say that dark matter is created by invisible three-toed gnomes behind the Crab Nebula that are throwing pixie dust into a black hole. Go ahead and falsify it.
And but how can you? All right, good point. Touche on that one. Falsify that laws are natural.
Well, that's what physical laws are natural laws. Natural.
Yeah, but you term physicality as by what you can observe. I term physicality
because that's what science.
As something I agree with and I think about. See, you got to understand something. You may look at something in your garage and says, hey, can you go get me that golf club over there in the corner? And I'll look at you and be like, what golf club? Right there in the corner. I don't see no golf club. Now, would that mean that there's not a golf club there? It all depends on what you how you would look at that. I may look over there and say to you, hey, there's not a golf club, and I go over there, and you thought that there was a golf club. When I walk over there to where you told me to go get the golf club, it's not there. And you're like, well, you know what? I could have swore I put it there yesterday.
Yeah. Okay, make an experiment.
How can I prove that it was there yesterday and you just forgot that it was there?
Well, publish the experiment. I want to see it.
Oh, Johnny, come on, man.
We're talking science here. I mean, you guys are saying the second law or the laws of thermodynamics.
Okay, the next show we're going to do is we're going to trace back the origination and genesis of the laws of thermodynamics.
Yeah, start with Rudolf Clausius. Yeah,
that's going to be the next show, people. We're going to trace back the origin of all of the laws of physics. That's what we're going to do.
I want them to post, like I said, I want them to post experiments that falsify the first and second law of thermodynamics, the pillars of science.
We'll do that. We'll do that, John.
Yeah, I'll tell you what, and call Nobel, because you're going to get a prize here.
Oh yeah, that's $5 million, isn't it?
You're going to get a prize for falsifying these two laws.
Isn't the Nobel Prize $5 million, right?
I don't know what it is now, but you're going to get one.
Yeah, I think it's $5 million. So here's the thing. I'm going to post another schedule for a show next week, and I'm going to put in the description the first two laws of thermodynamics for everyone. And then anybody who wants to watch the show next week, do your own research, come up with whatever you can, and our goal is to literally debunk John's first two laws of thermodynamics.
Yeah, I can't wait to see that.
And whatever information anybody else has got, we'll get it together, and hey, we'll submit an application for the Nobel Prize for Physics.
I want you're going to have to show how I can stand by a wood stove right beside it,
no. You
then
can't
back up 300 meters and spontaneously combust.
You can't.
That's what you're going to have to show.
No.
Yes,
That's not
yes.
John. You said debunk the first two laws of thermodynamics.
That's right.
We are all going to work to do that the way we want to do it, and you're either going to accept it or not accept it. Everyone's going to get an understanding of what the laws of thermodynamics are, the first two laws, and then we're going to find experiments that literally negate both of them.
And I just showed you what you're going to have to do. You're going to have to show me.
You're giving a hot stove experiment. Come on, man. No.
1 second. You're going to have to I'm going to tell you how big your abyss is. You're going to have to show me. You're going to have to show me how heat in my wood stove that's really hot when I'm close to it. When I back away 300 meters, how I get hotter. That's what you're going to have to show. Best wishes.
We're going to have to show how your hot stove is actually hotter when you're further away from it.
That's exact. I want you to show heat flowing uphill, brother.
Okay. Okay.
By itself.
By itself.
That's right.
All right, I'm gonna work on this. I'm gonna work on it. I'm gonna work on it. You give me a challenge. You give me a challenge.
I can't wait.
All right. Be ready. Be ready to burn your Bible too.
Yeah, right.
God ain't gonna have nothing to do with this.
I'll tell you what. You better get some ink, paper, and glue molecules out there in those instruction manuals.
Oh, dude.
And I want to see. I also want to see DNA, RNA, or a protein 30 mer for each wicker themselves together from their substrates naturally.
I told you I can do it with a 3D printer.
And then I want you to show me where the information is on those ink molecules.
Oh, dude. You know what? Yeah, I see how you're being like the professor that I'm having trouble with right now, dude. I see how you want to be.
Good luck.
Okay. Do we have any challenges for John? Anybody out there?
Bring them all on.
Anybody want to challenge John?
I mean, I want to challenge him too.
Hey, Larry. Larry said he wants to challenge. Larry Sibbins. He wants to challenge.
Right, bring them on. Bring them on to the next show. Bring them on the next show.
All right, we're gonna work on this. Listen, it's been good, people. It was a good one, this one, and we're gonna talk about the laws of thermodynamics next show. Work to put something together, and go from there. Again, people, remember, it's not what you know, it's what you can prove, and we're working to prove a lot of things, not necessarily disproving a lot of things, but proving a lot of what we believe, why we believe it, how we believe it. Key word is belief, all right? Because a belief has to turn into some sort of universal fact. Okay? Guys, thanks a lot, man. It definitely has been fun. And Luke, thank you very much. John, as usual, you and I probably going to be talking throughout the week and arguing about this offline.
Yes, we are.
And if anyone else has any questions, please feel free. As now, forever hold your peace. So you're definitely welcome to make your comments in chat. John does look at it. Luke looks at it. I look at it. We respond, maybe not to all, but, for those, that have a genuine curiosity. But,
hey, Robert.
Yeah, go ahead.
Hey, Robert, and just by a miracle coincidence, there's about 60 passages in that Bible. Then guess what they speak to?
What?
A flat, domed, non-spinning Earth. What a coincidence.
Yeah, I know that. I know that. But when you say non-spinning Earth, we're talking about the ground we walk on, drive on, and live on.
I just wanted to add that in there.
Okay, but we're not talking about the rest of the construct, the outer layer.
That's right. That's right. We're not.
Okay. Yeah, because I do agree with that. I do agree with it.
Just by coincidence.
We're trying to get an understanding for the rest of the construct, which is the outer layers, because there's some rotation going on. And when we talked about that whole gyroscopic idea, I'm starting to lean towards that now, and it'd be great to try to develop an experiment where we could try to, work to figure that out so that everyone can get a visual of how it would actually all work. So, but again, next show, the 2 laws of thermodynamics, and John's going to be submitting the application for the Nobel Peace Prize in Physics for the rest of us to share in the booty.
Hey, Robert, don't forget that first one right up here.
Dude, I know how you're gonna be with this. Don't worry. Listen. We may even surprise you with a few. Don't. So be ready. We may surprise you.
I'm ready right now.
Yeah, no, don't worry, because we're gonna have something for you too. I got something for you too. I got something I've been holding back. I wanna get you on.
Okay, wait a second. I got my Louisville Slugger right here.
Yeah. Hey, dude.
Okay, I'm ready.
I already threw you 2 curveballs, so you get 5 balls on that one.
They were watermelon hanging size curveballs.
Yeah, okay.
They already got Jackyard.
Yeah, but again, guys, it's been fun, man. So, you guys, peace out. Take care. Thank you for watching. Thank you for commenting. Thank you for being good to each other. And again, you got any questions, feel free. Email me. Email John. John, do they have your channel?
I just have a bogus channel up there. I don't have any videos or anything on it.
You want to put it up so people can they email you through your about section on your page?
Well, I'll just have them email through you.
Okay, okay. Everyone knows Luke's channel. Luke, give me your link in the thing so I can give it to everybody.
Hold on.
Oh shit. Yeah, hang on. I think I have it. Hang on.
So sorry, Robert. I forget you don't watch my videos.
Yeah, dude, I do. Come on, man, don't do that. Hold on, I got your link. I got your link.
Alright, go.
I think I got your link. Because I played it. Damn, what the hell? Okay, stand by here, people. Let me give you Luke's channel. If anybody has any questions, please ask now. Forever hold your peace. Forever hold your peace. For everyone wanting to know, here is Luke's channel.
Hi guys.
There you go.
Luke here.
All right, people.
Video earlier talking about
All right, people. You guys have a nice weekend. I know Bob and those guys doing some show tomorrow. They got some information they want to share to people. It's going to shock everybody. I ain't going to say what I got. Let's just put it this way. It's probably going to be something mind-blowing what they're going to tell everybody. So I don't know what time they're going to do it, but I know I'll be listening. Take care, people. And for the hammers out there, I really appreciate it. Russo, Holographic, who was the other guy? Holographic Invasion, I appreciate it. Fausto, thank you, Fausto. Flat Earth Forex, Wobbly Boost, Super Tampo, QN Fee, Colm Gibney, Neil, Marcus, of course. Marcus, you and I will chat probably later today, maybe tomorrow. Nate Smith, Juan Carlos, and Scientism, was it Bokakaya? Who else was in here? If I forgot anybody, I got nothing but love for all you guys, man. I appreciate it. Larry, be good to be people. All right? Take care. It's not what you know, it's what you can prove. Peace out.